From my YouTube channel, Electricity and Magnetism Vector Calculus. I assume you have watched my previous videos listed here. From episode 33, OpenGL Programming Guide 9, Indexed Drawing 2, glDrawElements. If you haven't watched my previous videos listed here, it might be difficult for you to follow my current and future sessions. Show more, download the current video source code, click it, show in folder, unzip it, rename 044 subroutine. In this folder, rename indexed.cpp to subroutine.cpp. Go up, copy this folder, paste it in your working directory. Open up Visual Studio Code, Electricity and Magnetism. From folder 44 subroutine, open up subroutine.cpp, indexed but Ctrl B. I will arrange side by side. If you haven't watched my previous videos listed here, it might be difficult for you to follow my current and future sessions. Now, fold it up. Right after aspect ratio, I will introduce GL plot degree 0, then GL int revolution axis. Right click, begin app declaration, go to definition. In this section, per million application, we can find on key. Copy this in the subroutine here, paste, remove virtual, then override. I will flash out switch code point case unsigned int x revolution axis 0 break paste y 1 z 2 default like this, then degree 0. Now scroll down. In the display function, we will delete this part. Static character axis over revolution x, y, z degree 1 plus f. We increment our degree. If degree greater than or equal to 360, we reset degree to default value 0. Then auto angle degree times 3.141592. This is 5 over 180 float. I will make it all float. This is radian angle. Now here SED C out angle, we display degree axis over revolution axis over revolution axis STD and there. Now scroll down. Projection matrix frustum, we'll change it to 50. Then model view matrix, I will make it -8. With this, open up this command prompt. Ugly looking bug. You should see Intel SQL OpenCL OpenGL Programming Guide 9th edition. CD 044 subroutine ICXCL subroutine .cpp at resp.txt, hit enter. CLS I. So you should see this message. Angles, axis of revolution is X. If you press Y, then this is axis of revolution Y. If you press G key, this is axis of revolution is G now. Now close it. Here, indexed vertex. We will create uniform plot angle. Then in this section, private, we will add GL int angle location. Scroll down in the function initialize. Here angle location GL uniform location. We pass program, copy this angle, paste it here. Now scroll down in the function display. Scroll down right before glDrawElements. In this section, GL uniform 1F angle location angle. We will build once again. Now close it. We will learn how to create subroutine in OpenGL programming. I will delete the comment here. Step 1. Declare the subroutine type. Subroutine backport, this is return type. Revolution figure. Plot angle backport position semicolon. This is our subroutine type. Step 2. Declare the subroutine functions. We use keyword subroutine parentheses. This subroutine name. Then return type should be this backport rotate with respect to X axis. Plot angle backport position. I will copy this text. If you control click in the Wikipedia, you can find rotation matrix here. This is 3x3 matrix, but in OpenGL we have to use 4x4 matrix. If you finished high school in Korea, it's very likely you have learned linear transformation in high school. These are rotation matrix. Rotation with respect to x-axis. Rotation with respect to y-axis. Rotation with respect to z-axis. You probably learned go, ma, shin, 코 와, 고, 신, 미, 신, 코 꼬마, 신, 코, 코, 신, 미, 신, 코 You probably learned these things in high school. Now, here, back4 T, back4, we translate 0, 0, 5 unit 0. Then mat4 R, mat4 1, 0, 0, 0. Copy this, paste. It should be 0 cosine angle minus sine angle. Copy, paste. It should be sine, cosine, then 0, 0, 0. It should be 1. I will make it arranged. Semicolon. Now return. We add T with the position. We actually translate position vector in the 5 units in the direction G. Then R times our translated vector. If you finished high school in Korea, you probably learned this rotation matrix in high school. Go, ma, shin, ko. Now copy this, paste. This is rotation with respect to y-axis. Now we translate 5 units along the x-axis. It should be 0. Our matrix should be fixed. I will simply delete cosine angle 0, sine angle 0, then 0, 1, 0, 0, then sine, negative sine angle 0, cosine angle 0, 0, 0, 0, 1. This is rotation with respect to y-axis. I got this matrix from here. Go, shin, mi, shin, ko. Go, shin, mi, shin, ko. Now copy this, paste. Rotation with respect to z-axis. We translate 5 units along the y-axis. Then I will fix this part. Cosine angle minus sine angle 0, 0. Copy, paste. It should be sine positive cosine 0, 0, 1, 0, 0, 0, 0, 1. The remainders are the same. Now, step 3, declare subroutine uniform. Subroutine uniform revolution figure. Please understand, we used this revolution figure. This is type. We need to create instance. Revolve figure. This part is type. This is instance name. Now we will consume this subroutine. Here, paste, angle, position. I will delete. Now in this file, scroll up in the private section. Here, GL U int revolve figures. I use the plural because I will make it array. Now scroll down in the function initialize. In this section, revolve figures 0 GL get subroutine index program. Please understand that we defined this subroutine in the Vertex shader. So GL Vertex shader. We pass this subroutine name here. Copy, paste. Revolve figure 1, rotate with respect to Y. Rotate with respect to Z. It should be. Now scroll down in the function display. Scroll down right before glDrawElements. GL uniform subroutine unsigned int vector. GL Vertex shader. So shader type is GL Vertex shader. Count 1. Then unsigned GLUint pointer. We created revolve figures. We pass revolution axis. It should be address. Now we rebuild CLS I. Please notice it is rotating with respect to, it is revolving with respect to x-axis. Right hand side is x-axis. Now press Y key. It is now revolving along the y-axis. Now z-axis, G key. It is revolving along the z-axis. The problem is that it is revolving clockwise. X-axis, it is revolving clockwise. Y-axis, it is revolving clockwise. Z, it is revolving clockwise. It is problematic. This documentation says counterclockwise orientation, but our implementation revolves clockwise direction. Now close it. The problem is here. In the subroutine, rotate with respect to x-axis. Rotation matrix R. This is not row 0, but column 0. This is not row 1, but column 1. You have to be very careful. This is column vector. This is column vector. So we have to transpose like this. In the same manner, we have to transpose. We have to transpose With this, we rebuild CLS I. Now it is rotating with respect to x-axis in the counterclockwise orientation. Press Y key, it is rotating with respect to y-axis in the counterclockwise direction. G key, it is now rotating with respect to z-axis counterclockwise direction. Now close it. In this part, instead of transpose, we can fix like this. We removed T. Instead, position has member XYZ five units. Then we can transpose, making it positive, making it negative. This is equivalent. CLS I. It is rotating counterclockwise orientation with respect to x-axis. Now close it. Don't fix your code like this, because this does not match with mathematics. Instead, restore it back. Make it crystal clear. We can optimize anytime, but if you optimize your code, the complexity of your code compounds uncontrollably. That means you cannot fix your code later. Try to make your code idiot-proof, crystal clear. Remember, idiot-proof, crystal clear coding